In this video, I'd like to discuss color bleed and how you can control it or manage color bleed in your scenes. Color bleed is what happens naturally when light is bounced across a room. As light hits objects, it transfers the color of those objects to other locations in the room. Probably some of the best examples of this, even though this is CG, it still represents what happens in the real world, would be these Cornell box tests that you can see. You can easily set these up yourself. Just make a box and put a light in it. And most of the times, as you can see, there's two different colored walls to kind of show the effect. But if I open one of these up and take a look, what you see is as the light is bounced around this room and travels throughout the areas of this room, once it hits something, it picks up some of the color of that object and transfers that in that light energy to other areas of the room. Now, even though this is a naturally occurring phenomenon, it can cause problems when you're trying to create a specific colored wall or do very specific looks in a scene, such as an interior like this. On an interior, like architectural interior renderings, it can really be an issue. Again, even though it's a natural occurring phenomenon, oftentimes you'll have a designer that says something like, I want the wall paint to be this specific color, and they may not understand that they have like a really orangish red colored hardwood floor and white walls, and then as the light travels and hits that hardwood floor, that orange color is transferred to the scene and you get these orangish colored walls. So let's just take a quick look at this, and what I've set up is just basically a Cornell box, if you will. It's more geared towards an architectural interior, but I just have a box with a photometric light inside and a couple of chairs. I've got a separate floor mesh here that we can change materials to see how this interacts with the light, but right now, material wise, everything has a uniform material on it, sort of this Arkin design material, sort of a light white here. Let me just change this to something like 0.9. And what I'll do is just give this a quick render so that we'll have a basis to work from. And so there's the base render, if you will, kind of a flat looking, very uniform, no frills render. Of course, this is using both final gather and global illumination. You have to have some form of indirect illumination in order to have light bouncing around in the room and for color bleed to happen. If I didn't have indirect illumination, there would be no color bleed because there's no bounce light for color bleed to occur. Okay, so what I'll do now is just go in and let's change this floor material and just see what happens. I'm just going to select the floor and let me just create, say, floor test material and apply this another Arkin design material. But this time, let's make this kind of a Hello Kitty hot pink, if you will. Give that a render. So as you can see, even though I've only changed the floor texture, everything in this room now has that pink hue to it. Again, because the light has traveled from the photometric light here down in and hit this very saturated pink color, and then bounced. As it bounced, it spreads that color around the room because some of that light has picked up that color as it's being bounced. Now there are a couple of things to note about this. One, if the material was not, or this color was not as saturated, obviously the color bleed effect would not be as intense. So for less saturated colors, naturally the color is not going to bleed out as much as what you see here. those very dark, bright, like bright pink and colors like that, will produce quite a bit of color bleed, whereas the more saturated, less saturated colors will not. So by decreasing the saturation, I've decreased the amount of color bleed here as well. Another thing to note is that reflectivity of the material also affects how much color bleed you have in the scene. Even if I increase this to more matte finish here, we have more color bleed than with a highly reflective finish on this floor. Now, even though I'm just using colors to demonstrate this, the principle holds true for bitmaps as well. Regardless of whatever you put in here, the color of that material is going to get transferred. For example, I have this, I guess this default wood floor. So regardless of what I put in for the color, the light is going to pick up that color and transfer it throughout the room. Let me just go ahead and make this a little less reflective. And I will cut the bitmap up and go back to this strong pink color. So what can you do if you need to control the color bleed? Well, there are two ways to look at this, because with Mental Ray and 3D Studio Max, you have two methods of indirect illumination. You have Final Gather and you have Global Illumination. Each needs to be addressed because if you can address one, which is Global Illumination, then you still may pick up color bleed from Final Gather. Or if you just address Final Gather, you could pick up color bleed from Global Illumination. If the goal is to completely eliminate color bleed, there's some solutions for that as well. So again, I will start with a base. I've got this pink color applied to the floor. So let me just go through it and run a quick render on this. Okay, I will go ahead and put this in the RAM player. And put this over to the side for now. And one option is that you can go into the object properties of this floor material. And if I just right click with the mouse and go to object properties, you'll see that there's a Mental Ray tab. Now under Final Gather, you can define how this object interacts with Final Gather. The first option, the default, is return the object color, which as you can see is the physically correct method. You can also have this return black or completely pass through and be invisible to Final Gather completely. What I'll do is set this for black and give that a render. And here you can see, you're probably thinking, okay, well, I still see color bleed. I still see pink here in the room, bounce light. Why is that? If it's set up for Final Gather to bounce a black color instead of the actual physical color, the reason for that is what I said a while ago. There are two methods of indirect illumination going on here. One is Final Gather, which we did address, and two is the global illumination, which are photons. What you see bounced here would be the global illumination, the photons, their contribution to the scene. If I bring back the RAM player and load this image in, you can see that a lot of the color bleed was reduced. That's because naturally this floor is returning a black color when Final Gather hits it. And you can see that effect here best on these chairs. So how do we address, if you're using both methods of calculation, what do you do to address? What we're going to do is, obviously this object is not transparent, so you'll leave that to black. The specular, as far as how reflective is it, it's about medium, so I'm just going to put that down to somewhere like 0.5. And for the diffuse color, what color, basically if you want to think of this as what color do I want to bounce? When a photon hits me, what color is it going to see? And you can put black in here, but then you won't have any bounce light. just to show that, let me just go ahead and put black. Because as you saw in that last render, even with Final Gather, with this being black, you're not getting a lot of bounce light. And so with that set up, let me give this a render. And so now we have 0 color bleed. Global illumination is not picking up any color. It sees black, as well as Final Gather on that object. When the Final Gather rays hit it, it only sees black. As such, you're not going to get a lot of bounce light in the scene. And obviously this looks very unrealistic. That being said, sometimes you have to break the laws of physics in order to please your client. So that's the whole point of this video tutorial, is to show you how to do this. So let me go in now and let's just break this down. Let me turn off Final Gather, and let's look at this again in a singular approach. Let's just look at it through global illumination. So what I'll do is go back to the original Arc Design material here and let it calculate final global illumination on its own. So to do that, I'm just going to leave that in there for now. If I click this lock button, then what that's going to tell that material is to use its own built-in photon shader instead of the one that I've assigned here. So let me give this a render, and this should go pretty quick, so I'm just going to let it go through. Obviously, as you can see, this is just the photon pass. So these photons are bouncing and they're picking up the color as you would expect and transferring it through the scene. Once this render is complete, I'll go in and unlock that shader. And so now I'm telling it, instead of using your own built-in photon shader, use the one that we've assigned here, which is going to return black. Now we have no color bleed. Now you could even do some crazy things like have this bleed a different color or see a different color. For example, if I wanted to put green for the diffuse color, what we'll get now is green color bleed with a pink wall. So we have a very own watermelon room now. So that's kind of how you can break the laws of physics, if you will, with these photons. And all of this is to get a specific look or control the color bleed, which again is a naturally occurring phenomenon. Let me just put this back to basically one thing that I like to do if you have to do this is you may want to put this to like a medium gray, so that you will still get some bounce light, but it'll be a neutral color. So I'll just leave that at the medium gray. And let's go in and now let's just cut off photons completely here. And let's focus on the Final Gather. So what I need to do is go in and actually give this some bounces now. Something like so ought to work. And I'm just going to leave it at the low preset. So it's not going to be very pretty, but it'll get the point across. And as you can see, as this is calculating, we have no color bleed, because remember I've gone in and set this object up so that when Final Gather hits this object, it just sees a black object instead of whatever color may be there. I set that for refracted rays, which we have none here. Let me just change that to Final Gather. Just swap those. And so we have the watermelon room again, because again we're giving it we're defining the Final Gather rays of being green and the eye rays, which is what you would see, being this pink color. One thing to keep in mind when you assign this ray type switcher to this material, you are now controlling all of these rays for this material, and that's important to know if you have other objects in this scene, how they interact with this particular material. Because right now I've assigned the eye rays, which is what we see. I've also assigned the Final Gather rays, which controls how Final Gather interacts with this object or this material. But for these other options, they're still at the default black color. So what happens if I have some transparent objects in the scene, or something that reflects this object a little more? To show that, let me put in a couple of objects here. And I'm just going to drop some spheres in. Move these like so. Maybe put one there and one here. That looks better. Okay, now I'm going to make one of these a glass sphere, and one will be a chrome material. Just make this chrome, and I'm just going to use the chrome preset. I'll call this glass, and you guessed it, glass preset. As you can see, I have instancing enabled here, a material instancing, because when I apply one material to this instance sphere, it applies it to both. That's an option that's automatically enabled in 2010 design, so that's something that wasn't enabled in 2009, so it kind of catches you off guard. So now I'll be able to put a different material on this instance sphere. Okay, and so let me go back to this material, and so that we can see this ray type switcher, and give this a render. Now the glass material here, it's returning a black color for this object, and the chrome material is also returning a black color in its reflection. So it's seeing a refractive color of black, and it's seeing a reflective color of black. And so while this material is applied to this, or this shader, this ray type switcher is applied to this floor test, this pink material, it also affects the other objects in the scene in that how they see this material, just like we see it in the rendering here. So what they're seeing is this chrome material is seeing the reflected rays as black. This glass material is catching the refracted rays as black as well. So what I can do is, just to make this more interesting, I'll just put a blue color for the reflected rays, and let's say yellow for the refracted rays. So now the glass object is seeing this refracted as yellow, while the chrome object is seeing it reflected as blue, even though it's a pink object. So you'll need to set this up depending on your scene for how this interacts with other objects in your material. So don't think of this as simply a final gather trick. You have to consider how other objects see the rays here from this particular material. And so while I've gone through and I've used the color swatches here, you can see that there's a button here to the right of there. If you need to use materials instead, of course you can assign materials to this instead of colors. If I go back to this wood material here, what I want to do, let's use this as a real world example, if you will. What I would want to do here is go in and assign that to the eye rays, reflected. I'm just going to copy it as an instance, refracted. And then for final gather rays, let me just change these to black so it's less confusing. And then for final gather rays, if I wanted to control color bleed, maybe set that to something like medium gray. If I needed to control the environment rays or shadow rays, of course I would change that to whatever, or instance my map down to those if need be. For this particular scene, I don't need to worry about those. Now a quick note about this final gather rays, the color that I use here. You may be wondering why I chose a medium gray instead of, say, white. The reason for that is this is going to control the intensity that the color that the final gather indirect bounce light produces in this scene. Since this floor is kind of a dark color, I don't want to put a whole lot of bounce light in here where this object is seen as a pure white object of final gather. So that's why I went with kind of a medium gray. In fact, I'll show you the difference. Let me just load this into RAM Player, like so. Slide that out of the way, and I'll just change this to white. Okay, let me just put this new render in the RAM Player. And you can see the difference in the brightness of that indirect illumination. Again, that just comes to personal taste. Your client may actually prefer the brighter color, who knows. But that's just the reason why I chose a medium gray for the final gather rays instead of a pure white. Okay, so now I'll return the scene back to its normal state where it's using both final gather and indirect illumination. Optimize for final gather, and no bounces here. This bounce is actually ignored. The final gather bounce is ignored whenever you enable global illumination. So let me close that, and what we have is I'm controlling final gather now on this material via the ray type switcher, and I'm controlling the global illumination, how it interacts with this particular material with this photon basic shader. And so now if I render this, everything should look correct, but I will have no color bleed in this scene. And so that's how you can control color bleed that you'll have in your scenes. And mainly I looked at this through an architectural interior focus. There is another point here to be made about color bleed, and that would be the surface imperfections and how surface imperfections play a role in how much color bleed you have in a scene as well. This isn't a good example scene to use for that. I have another one that I'm going to switch to for that little discussion. So let me just load this scene up. I'll just say yes. Let me just load this scene. So what I have here is sort of a typical, if you will, exterior type scene. I have a mental ray, sun and sky in this daylight system. I have a ground plane and just a couple of objects that will pick up the color bleed in the form of the indirect illumination from this ground plane. So obviously, as you can tell, if I render this scene now, I will probably have a lot of, or a good bit of color bleed. On exteriors for outside type scenes, you're not going to get a huge amount of color bleed, but you will get some. So let me just go ahead and render this as a base. And so here, as you can see, I have a good amount of color bleed. The reason that I'm using this scene is because I've received some questions in the past about why buildings turn green when they're sitting on a grass object, things like that. And a lot of times the material that they'll have on for the grass will be a rather strong chartreuse or very bright green like this. So obviously one thing that you could do is apply a darker material to it, but if you had to use something like this, if the grass texture that you have is a more bright color than what you'd like, you're going to get some color bleed. That's just a natural event, and I've showed in the previous you can use the principles that I showed in the previous example to manually control that here if need be. The point of the discussion here though is that a grass surface, if you will, also has a lot of blades. Naturally, the grass blades, as light goes into the grass blades, it's scattered about, so you don't actually get a lot of color bleeding from a grass surface. To show that, what I'll do is, let me just bring that back and load that into the RAM player. Here we go. Slide that out of the way. And I've got some proxy grass objects here that I've created. So I may have those on a layer. Nope. Let me just unhide. Yeah, grass proxy objects. And these have the same material applied to them as this ground plane. So let me render that. Okay, let me put this in the RAM player. So as you can see, that cut down on some of the color bleed just by breaking up that surface and putting these grass blades in the scene. I've eliminated a good amount of that color bleed. In that last scene, that interior scene, where there's perfectly flat floors and walls and things like that, you also get a lot of color bleed just because there's nothing to break up that light. It can just bounce that color straight around in the room. Versus on a scene like this, where the light comes in, hits these grass blades, and it's just scattered in all different directions. Another condition to think about for this particular scenario is the grass material itself. Obviously, this is not a realistic attempt at grass. This is not how your yard looks, or at least I hope not. Grass blades themselves are actually kind of translucent. So what you'd have is the light comes in and it's just scattered about, but also some of these grass blades will absorb some of the light. So for this particular setup, what I would do is go in and on this ground plane, I would probably, instead of using a solid color like that, you're going to want something, well, like dirt or earth, something along those lines. And for the grass blades, what I would do is assign something like this fast SSS material, which will actually absorb some of the light like you would expect from grass blades. So did I apply that? Let me apply that. And let me just load this one in the RAM player. And so what this would do is give a more realistic result naturally, but it will also should act more so like what you would get as far as color bleed, what you would see actually on a grassy area, I would assume. So let me move this out of the way. Go ahead and render. Okay, let me bring the RAM player back in and add this render to it. So obviously there's a color difference here, but you can also see how the color bleed is controlled by using this subsurface scattering material on this grass blade. What that does is that the light comes in and actually is absorbed by that material, but also it goes into that grass and is scattered about, so you don't get a whole lot of color bleed, just as you probably wouldn't in the real world with this particular setup. So with that, that will conclude the discussion on color bleed, and I hope the video helped.